Find the perimeter and area of the triangle graph below. Round your answer to the nearest tenth if necessary. Well, when we're finding the perimeter and area, whether it's a triangle or later on when it's a rectangle or parallelogram or rhombus, some sort of quadrilateral, we need to use the Pythagorean theorem. And the nice part is we can find one of the distances of one of the sides of our triangle. 1, 2, 3, 4. But the other two we have to do the Pythagorean theorem. So if we draw in our triangle, we have 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So when we set this up, we have 3 squared plus 7 squared equals c squared. 9 plus 49 equals c squared. 58 equals c squared. And type it into Desmos, type it into your graphing calculator. When I pull this up, square root of 58 is 7.6. We need to do one more side over here. And here is our triangle. One space here, and then 1, 2, 3, 4, 5, 6, 7. So we've got 1 squared plus 7 squared equals c squared. 1 plus 49 equals c squared. 50 equals c squared. And again, use Desmos, use your calculator. Take the square root of 50 and the square root of 50. It's 7.1 when we round. We're looking at this 7 to round to the nearest tenth, and I better go back and look and see what I specified, but I'm going to go to the nearest tenth for now. So c equals 7.1, and it does say to the nearest tenth, which is 1 decimal place. So again, when we're finding the perimeter, what we just found is we had the 4 originally, and then we added to that the 7.6, and we're going to add to that the 7.1. 4 plus 7.6 plus 7.1 gives us 18.7. The area of the triangle, the formula is 1/2 times base times height. And if we look here, our base happens to be that blue number that we found first. It's 4. And the height, well, the nice part is we can draw in the height here. And the height of this is 7. 1, 2, 3, 4, 5, 6, 7. So 4 times 7 times 1/2. And if you need to, you can type that in, but we end up then with this being 14 units squared. Number 2, find the area of each triangle below. Round your answer to the nearest tenth if necessary. And what we have to do on our equilateral triangle is we need to find the height in here. So if we draw in the height, I'm going to call it x because sometimes now that we've done hypotenuse, people get it confused. But when we draw in the height here, it actually turns out that it's a perpendicular bisector. So that means that this length is 8 and this length is 8. An equilateral triangle has 3 congruent sides, so this is 16, and we're going to use the Pythagorean theorem to figure out that value here, which is going to be 8 squared plus x squared equals 16 squared. And 8 squared is 64 plus x squared equals 256. If we subtract 64 from both sides, we end up x squared equals 192. I'm going to check my math real quick. 256 minus 64, yes, is 192. And then if we take the square root of 192, we end up with 13.85. And again, remember, if we're rounding to the nearest tenth, we have to look at the 5 to determine what to do to the 8. And because 5 is 5 or higher, that's going to be 13.9 for our value here. And what we did is we took the square root of both sides. But now we can find the area of the triangle, because what we've got is we've got a base of 16. We just found the height of 13.9. And we're going to multiply it by 1/2. We're going to divide by 2, whichever way works for us. And when we type that in, we type in 0.5 for 1/2. So 0.5 times 16 times 13.9. And we get 111.2. So our area is 111.2. Oh, and we can make it yards squared. Isosceles triangle. Same idea when we figure out the height. I'm using the Pythagorean theorem. And once again, what we have is we have a perpendicular bisector. So this dotted line is the perpendicular bisector, which means that this length is 6 and this length is 6. Again, I'll call the height x. And we use the Pythagorean theorem, and we have 6 squared plus x squared equals 9 squared. Remember that it's side squared plus side squared equals hypotenuse squared. So we get 36 plus x squared equals 81. We're going to subtract 36 from both sides. And we get x squared equals 45. Again, I'll check my math here as we get ready to take the square root of that. But 81 minus 36, there's the 45, and then we take the square root of 45, which gives us 6.70, so we're going to leave it as 6.7. We took the square root of both sides, so x equals 6.7. And again, our formula for the area is it's 1/2 times base times height. So it's going to be 1/2, our base is 12, and then our height is the value we just found, which is the 6.7, and we type that in. So I'm going to use 0.5 for 1/2, so 0.5 times 12 times 6.7 gives us 40.2, and we get 40.2 feet squared for our area. Number 3. What is the midpoint of the segment AB with endpoints -2, 7 and -3, -4? And first of all, what we're going to do is we're going to draw in these points. -2, 7. Here's A. -3, -4. Here's B. And I'm going to start at B, and I'm going to draw a triangle in, so to speak. I didn't completely draw the triangle, but that's okay. Because what we're looking here is to get from B to A, we went up. We went up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We went up 11. and then we went right 1. So when we're finding the midpoint, we're going halfway between. So instead of going up 11, we're really going to go up half of that value. So half of 11 is 5.5. And instead of going right 1, we're going to go half of that distance. Well, half of 1 is 0.5. So if we go back and count, again, remember we started with B when we did this. So we're going to count 1, 2, 3, 4, 5.5, and then right 0.5. So there's our point. And then what our midpoint is that red point there. The midpoint is negative 2.5. And then we went up 1.5. Number 4, write the equation of a line that is parallel to the line y equals 3/4 x minus 1 and passes through the point 12, 10. Well, the thing that we need to know about parallel lines is that they have congruent slopes, and luckily for us, this equation is already in slope-intercept form. The slope of our line in this particular problem is 3/4. If you think back, y equals mx plus b. So when we write this here, we're going to put our equation back into the formula. Y minus y1 equals m times x minus x1. We don't need to simplify this, at least not much, when we do these problems, because here is x1 and here is y1. We know our slope. It's going to be y minus 10 equals 3/4 times x minus 12. And that's all we need to do on the problem. We don't need to simplify it. We don't need to put it in slope-intercept form. We can leave it in that format. Problem number 5. Line P has a slope of -3, and it's perpendicular to a line that passes through the point -4, 7. So first of all, when we take a look at this particular problem, what we see is that the slope, remember the slope is abbreviated with m, is -3/1, if I write it like that. And the reason that I do that is because the perpendicular slope is the opposite reciprocal. So the opposite reciprocal means that we're going to flip that fraction and we're going to change the sign. So -3/1, we flipped it, and since -3 was our original slope, our perpendicular slope is going to be the opposite sign of that, which is positive. And now that we have that, here's our x1 and here's our y1. Again, we're going to put it back into the formula. Y minus y1 equals f times x minus x1. And when we fill this in, we get y minus 7 equals 1/3 using the perpendicular slope times x minus a -4. And you can leave it like that on the OST test if you have to take that test. But I do want to say that more than likely, this would be simplified just a teeny bit more into minus a negative is a positive. Segment XY. Segment XY has a midpoint at 5, -2. If endpoint X is at 8, -7, what are the coordinates of endpoint Y? Be really, really careful on this one. Use Desmos. Draw your picture to help you with this, but let's graph and really be careful about labeling. What we have here is we have 5, -2. That's our midpoint. So we're going to call it F. And X is at 8, -7. Here's X. And we want to figure out what Y is. Again, M is the midpoint. So that's the middle value. We want to find the other endpoint. And again, it's going to be about counting. I'm going to go here. Ooh, try that again. Fix my M. And what we did is we went up 1, 2, 3, 4, 5. We went up 5. And we went left 1, 2, 3. That's our midpoint here. This red point now is the midpoint. So what we're going to do again is we're going to go up 1, 2, 3, 4, 5, and left 3. 1, 2, 3. And this point here is our value of y, and that ordered pair is 2, 3.